What I want to do is take a moment just to go through how to set up an application inside ACE. So this is just going to be a basic pick and place application, and then we can also show how to customizing it. So if you want to show how to maybe do like destacking, how we would go about doing that. So the way we do it when we open ACE is we go to a new sample application, and then we're going to go ahead and click on this ACE site. Smart controller pick and place sample, and this will take us into a wizard for an application. So we are going to do follow the wizard, and it kind of gives you these steps, and we're doing this in emulation mode, but in all honesty, the process when you have this on a physical robot is actually essentially identical. It will just be that when you teach the points, you have to move the robot into position, whereas we'll just kind of drag the 3D emulation in this case. So we'll click next. It's going to ask us a few questions. So the first thing, how will the parts be presented to the robot? So we're going to be looking at a fixed position because we're just going to have a stack of parts that are always going to be in that same spot. And then if you wanted to have high accuracy vision refinement after you pick the part up, you can do that, but most applications don't do that, so we'll just say no. And then we're going to be placing the parts onto a fixed position as well. So whether that's a fixed spot or even if you're doing stacking, either way you can do it with a fixed position. So now that we've kind of defined what that process looks like, we click finish. And then we're going to have to go through and do some setup. So since we're in emulation mode, we'll just use the IP address of the local host, 127.0.0.1. And it's going to build, it's going to actually run the exact same software that runs on the controller, but it's going to run it on my computer here. And then we'll select the robot. So I'm going to select a Cobra 650, and I just assign it over there. And it restarts the controller software now that it knows there's actually a robot there. Then it'll ask us for the different signals. So do we have signals for grippers or vacuums? And we can assign that. And then the other thing we would do if we actually had a real robot is we may want to put a tool offset in there. So if you ever change tools, you're teaching the points based off of the tool offset rather than the end of the robot. So you could go through the wizard and actually do that setup as well. So next thing we have to do is we have to define a safe position. So usually the way the safe position works is if for some reason the robot comes to a stop during the process, it will go vertical up to the height that is defined by the safe position. So in this case, it's almost as high as it can go, not quite as high as it can go, but this is usually a good starting point. But in a physical robot, you'd want to make sure that wherever the safe position is, the height of the tooling would be above anything that it could potentially hit. So we'll click next, and then we'll start jumping into the pick position. So physically, if you had a robot, you would actually move the robot into position and teach it. Now with the emulation software, I can click on the robot head and I can drag it somewhere over here. So we'll drag it, I don't know, this looks about good right here. Yeah, 175 looks good. Okay. So now what we can do is we say here, and that here just teaches that position as the pick position. And then next thing we do is we jump over to the place position. So now I can grab the robot end of arm again. And if you watch, when I mouse over it and I can grab it, I get an XYZ axis kind of appearance icon. And then I can just drag it over to some other place. And let's just say there looks good. And I hit the here button, and that stores that point as the place position. Okay, and it basically tells me I've finished doing the setup for that. And so now what I can do is I will open up the 3D emulation over here on the right, make it a little bit bigger. And then if I go to this main task, I can say execute on task 0 and go back to the visualization. And it's just going to run that basic pick and place routine. So you can see we've been doing this for about 5 minutes, maybe not even 5 minutes, and we've already got the basic pick and place routine going. Okay, so let's go ahead. We will stop that task. And now what we want to do is we want to make it so that we can actually customize it a little bit. So this main routine is the routine that it runs. So there's some initial setup that it runs, and then it gets into this main processing loop, and it does a call to a rob.pick and then a call to a rob.place. And the rob.pick and rob.place are just subroutines that go to the pick location and then go to the place location. So if we wanted, though, to have this do some destacking, then there's some additional things we may want to throw into the program. And so we can add some variables. So we can add some real variables, and let's do like pick.layer for the layer number that we would currently be at. We could also do say pick.max layer, and we would use that to be the what's the number of layers that we're going to have. The other thing we would want to have is what is the layer thickness. Now, I'm using a period between the letters. The period means it's not any sort of structure or anything. It's just kind of the way that ACE is typically defaulted to separate words in their variables, just kind of how they go about doing it. And then we also want to initialize these variables. So we want to set values to these prior to running the main loop. So we can say pick.layer. Initially, we're going to be at 0. And then pick.max layer, I'll set that to 10, saying that we would have a total number of 10 layers. So what we'll actually do is count 0 through 9. And then for the thickness layer, let's just say we have 15 millimeters per layer that we would want to be picking up. Okay, so now what we do is in the main loop, we do a pick, and what we want to do is simply say pick.layer equals pick.layer plus 1. We've finished that particular layer, so let's just add 1 to the pick.layer. But before we move on to doing the place, the other thing we want to do is just check to see if we've maxed out what the what that pick layer is, if we've reached our max layer, because if we do that, then we want to go back to 0 and start picking again at the first layer. So we can just use a simple if statement. So if pick.layer is equal to pick.max layer, then, and we'll just set pick.layer back to 0, and we can say end. Okay, so that's all well and good. So now what we'll do, though, is we need to modify the pick routine. And what I'm going to do inside the pick routine is I'm going to add kind of an intermediary point, and I'm going to call that the layer.pick. So this is where we're actually going to pick for a particular layer. So pick.loc is the location that we taught it to pick from, but then layer.pick is where we'll actually go for each layer. And the way we can do this is there's some math that can be done using the positions. And what I can say here is I can say set layer.pick, which is a way of assigning a location to this variable, equals pick.loc. And if I put a colon and then I use the trans command, which is a transformation, I can do some math onto the pick.loc location. So what I'll do is I'll say, this uses Euler's formula, so X, Y, Z, and then yaw, pitch, and roll. So I don't want to change the X and Y value. We want to pick from the same X and Y value each time. But what we do want to do is offset our pick location down by the thickness layer each time. So what I'll say is I'll say layer.thickness. That's the global variable that we set in the main program. And we're going to multiply that times our pick layer. So since we're going 0 through 9, on that first layer, we won't actually adjust anything. We'll just pick at the pick.loc. But then as we go through subsequent layers, we're going to adjust it by the thickness layer each time. And we're not going to adjust the orientation of the yaw, pitch, and roll either. And then the only other thing I need to do is these are approach and move commands. So approach is you're moving to a point at an offset in the tool Z's direction. So at this point, we're doing an approach to pick.loc at an offset of 25 millimeters. So we'll go to the X and Y value of pick.loc, but we're going to be up 25, and then we go straight down to the actual pick.loc. So that just gets us over it, and then we move down to it. And then the APRO-S, we do the same thing. We just do a straight up move 25 millimeters up. But instead of going to pick.loc, we actually want to set this to layer.pick. So I'll set, we're going to move to that layer.pick. And then we also need to do this approach to layer.pick. Okay. And then we'll come back to main and visualization. And I'm going to set this rob.main to execute on task 0. And if we go back to it, what we should start seeing is, this point right here is our initial taught point. That's our first pick.loc. And what we're seeing is every time it goes back to it, it gets a little deeper and a little deeper and a little deeper. And it's going down by 15 millimeters each time because that's what we set as our layer thickness. And then eventually, once we reach 10 layers, it just went back to the top. And now it'll go back through, going 15 millimeters deeper each time that we run this routine. So in a matter of about 11 minutes or so, we've managed to use the wizard to set up a pick and place routine and then also add in the vertical offsets for doing destacking. So it's a pretty easy process, and if you wanted to stack on the other side, you can basically do the exact same process with that layer thickness and doing offsets of the Z distance. It's just it'll be going in the opposite direction, and then you will be good to go from there. So that is how easy it is to set up a pick and place destacking inside of ACE EV+.